So let's start off by talking about decision making. Decision making controls the flow of execution based on specific conditions. So let's look at this in plain English first. Let's say we have a condition, which is for an exam, the pass mark is 50. We then have a decision, which is, did this student score more than 50? And then we have two branches with different outcomes. The first branch is the no branch, where the outcome would be the student fails. The second branch is the yes branch, where the outcome is the student passes. So let's now convert this scenario into JavaScript. Our condition is the pass mark is 50. So in JavaScript, we would write it like this. The score is greater than or equal to 50. And then for the no branch, now let's say the value of the score is 40. We know that in JavaScript, if we were to evaluate is 40 greater than or equal to 50, we would get false. And we could output a string like failed. For the other scenario, let's say the value of score was 60. 60 is greater than or equal to 50. So executing that code would result in the Boolean value true. And we could output a string like passed. So how do we actually code this up in JavaScript? We do this using the if statement. The if statement evaluates a condition and executes a code block if the condition is true. We use the if JavaScript keyword. We then have a set of parentheses which contains a condition. And this is the condition being tested. And then for the outcome, we use a set of curly brackets like this and execute the code inside the curly brackets. For this example, we'll just do console.log passed. So this console.log statement is code that is executed if the condition is true. So let's walk through exactly what's happening step by step. The condition inside the if statement is evaluated to a Boolean true or false, determining whether the code block executes. So let's first look at the case when the condition fails. We have our if statement we just saw before, and let's say the score the student achieves is 25. So we would have a variable score equals 25. So looking in the parentheses now where the condition is, if score is 25, this is saying, is 25 greater than 50? Now what happens here is that anything inside those parentheses is evaluated to a true or false. So 25 greater than 50, this would result in the Boolean value false. Because the condition is false, the code does not execute inside our curly brackets. So console.log would not be executed. Let's now look at the case when the condition passes. We have our same if statement. Let's say now the score is 60. Inside our parentheses, we would have 60 greater than 50. 60 is greater than 50. So this would result in true. And because inside the parentheses, the condition is true, the code now executes. So what's really important to realize is that inside the parentheses, JavaScript is executing what's inside there to give us a true or false value. And if it turns out to be true, the code inside the curly brackets will be executed, whereas if it's false, the code inside the curly brackets won't be executed. So let's go play around with this inside VS Code. Okay, so I've gone ahead and created a new index.html file, and I've linked a style sheet called app.js. Inside app.js, I just have this comment, which has train ticket prices for different ages. Up to 12 years old, it's $10. A standard fee for adults is $20, and 65 and above is $12. So as we move through this video and learn more about the if statement, I'll be continuing to add to this example. So let me first go initialize a variable called age, and I'm going to set its value to 8. I'm then going to initialize a ticket price variable, but I'm not going to set it a value because the value is going to be calculated based on these different conditions. So let's go add a single if statement. We grab our if keyword, we then hit space, grab our parentheses, and insert our condition. So we'll first check this condition here, up to 12. That would be age less than or equal to 12. The reason it's equal to is because it includes 12-year-olds. We then grab our curly brackets and hit enter. And inside here is the code block that will execute if this condition is true. For us, we want to go set the ticket price. So I'm going to set ticket price equal to 10, which is the $10 fee over here. So let's now go add a console.log so we can see this value outputted in the console. I'm going to be using a temperate literal with backticks to write the sentence ticket price is, and then grab our $ and curly brackets for the embedded expression and add in the variable ticket price. All right, let's go check this out in the console. Okay, great. You can see we get ticket price is 10. Let's just make this a bit more readable, and I'm going to put another $ here, which will output the $ here. So don't let that confuse you. This $ and curly brackets is for the embedded expression inside the temperate literal, and this $ is the actual symbol for dollars. Now, the reason this code runs is because this condition is true. The variable age for us is 8. So this is saying is 8 less than or equal to 12? Well, that's true. And because that's true, this code block runs. Let's now change the value of age to 20. If I refresh, we actually get back this ticket price is undefined. The reason it's undefined is because we're just initializing the ticket price value here, and this condition now fails. So this is saying, is 20 less than or equal to 12? Inside the brackets, this is evaluated to a Boolean true or false. 20 is not less than 12, so this is false, which means that this code is not executed, which means we don't actually have a value for ticket price yet. So when we're trying to output it here, the console's trying to access the value of ticket price, but it has no value, so it's currently undefined. All right, I'm just going to come and change this back to what it was, age less than or equal to 12, and I'll change this back to 8. I'll refresh, and now we're back to what we had. Okay, so this is a good start, but it's only handling one case. So how do we go and add the ticket price for the other cases here? So let's take a look at the else keyword. Else creates a binary choice where one block runs if true and the other if false. So looking back at our exam example, we had if score greater than or equal to 50, we output passed. So the console.log is running when the condition is true. What we can then do is extend our if statement with the else keyword, and it's positioned next to the closing curly bracket of the if statement. Next to the else statement, we then add its own curly brackets and add in the block of code we'd like to execute. In this case, failed. So this block of code contained in the else statement is going to execute when the condition is false. So the if else statement allows us to execute code when the condition is true, and also allows us to execute code if the condition is false. The else statement acts as a catch-all for all other cases. So let's go play around with this inside VS Code. So back in our ticket pricing example, let's go add an else statement and just give the standard ticket price of $20. So I'll just copy this and change the ticket price to 20. Okay, let's refresh. So when our age is 8, our ticket price is $10. Let's go change the age to 30. I'll refresh, you'll see it's $20. So this is working. But the important thing to note about the else, as I mentioned earlier, is that it is a catch-all case. So for example, if I change this value to 80 and refresh, we get back 20. But we know that for 65 and above, it should be $12. So that's what I mean by else being a catch-all. If this turns out to be false, this will always run no matter what. And this can actually cause some errors. So for example, if I put the age of 1,000 and refresh, the ticket price is still $20. But we probably do want some additional logic to say you entered the age wrong, because no one lives to 1,000 years old. So I just want to highlight that the else really is a catch-all. If this fails, then no matter what the value of age is, this will be outputted. All right, so the next thing we need to work out is how do we handle this case here? That when our age is 80, we're able to output the ticket price of $12. The if-else statement is useful for a binary choice, like the exam pass-fail we looked at earlier. So to be able to do this, we need to learn about the else-if keyword. Else-if checks multiple conditions and executes the first block of code where the condition is true. So back to our exam example, I no longer want it to just be pass or fail, but I actually want it to output a grade like A, B, C, etc., depending on how they scored. So we would have an if block like this, which is if score greater than 90, output to the console A. This is now our primary check. We then use the else if keyword, which has its own condition tied to it. So in this example, it's asking, is the score greater than 80? We then add our curly brackets and execute code if this is true. The great thing about the else if statement is we can add as many as we like. We can then add another else if keyword, which in this case is asking in the condition, is the score greater than 70? We then add our curly brackets, and we could output to the console the grade C. So these two else if statements are acting as secondary checks. We're moving from top to bottom, and as soon as any one of these passes, the code inside them will execute. So we first check, is the score greater than 90? If not, we then check, is the score greater than 80? If not, we then check, is the score greater than 70? And then we'd finally use the else keyword and execute code, like failed, and this else statement acts as a final catch-all. So effectively, if the score is not greater than 70, we're just going to output fail, where in this example, the fail mark is less than 70. So let's go play around with this inside VS Code. All right, I'm going to scoot this down, and I'm going to add a else if statement like this, and we're going to go handle the 65 and above case. So we're going to do, is age greater than or equal to 65? I'll add in some curly brackets, hit enter, and I'm now going to move this else statement back over here, ensuring there's a space between each of the curly brackets. Now, when the age is greater than 65, we want our ticket price to be $12. So I'll copy this and change its value to 12. All right, let's check this out in the console. I'll refresh over here, and great, our age is 80, so we're getting back $12. Let's go through all the cases. Let's do an age less than 12, I'll do 10. Our ticket price is $10, which is what we want. Let's now go do the age of 30. You can see we get back $20, which is what we want, and add an age of 90. I'll refresh, and you'll see we get back $12. Now, one thing I really want to highlight is that depending on what we're trying to achieve, we could be using a single if statement, we could be using an if-else statement, or we could be using if, else if, and else like we have here. So the example we've done here is a great example of using all three keywords. And this is because we're checking multiple conditions and executing different code for each. I now want to go through a real example of where you would just use a single if statement. As I'm sure you've seen on some web applications, in the top right, there's often a toggle to turn on dark mode, which is a darker version of the web page. So down here, I'm going to go initialize a new variable, let dark mode equal true, which means the user has turned on dark mode. I'm then going to grab the if keyword, grab our condition, and I'm going to check, is dark mode equal to true? Now we're going to be using the strict equality operator here. This is effectively asking, is the value of dark mode equal to true? Now just to highlight something, because it confused me when I started out, a single equals is used for assignment. I spoke about this in an earlier video where JavaScript is not like maths, and a single equal sign is used for assigning values to variables. When we want to check if something's equal in JavaScript, we either need to use the strict equality with 3 equal signs, or the loose equality with 2 equal signs. And as I have mentioned earlier, the strict equality is much more commonly used. So this effectively is asking, is dark mode equal to true? If that's the case, let's just output to the console, show dark mode. Okay, I'll refresh the console, and you can see over here, because the value of dark mode is set to true, we are showing dark mode. Now just to step you through the logic here, so it's crystal clear, the value of dark mode is true. So let's go replace dark mode with true. This condition is saying, is true strictly equal to true? Well, that is true. True is equal to true. So the evaluation of that is true. Now at the end of the day, inside our condition here, we're executing a Boolean context, which ultimately results in true or false. Because we end up with true here, this statement will run. All right, just putting it back to what it was. Now, if I set this to false, I'll refresh, and you can see this is not executed, so dark mode would not be turned on. Now, also stepping you through the logic here, dark mode is currently set to false. So inside the condition, we're evaluating, is false strictly equal to true? Well, false is not strictly equal to true, so the result of that is false. And because inside our condition, we're left with false, this code block won't run. All right, just putting it back to how it was. So here's a great example of where you'd use a single if statement. When I started out, I was under the impression it's kind of like you want to achieve if, else if, and else. That's not the case. This scenario is used when you need to check multiple conditions. A single if statement is when you just want to run code under one condition, which I do want to highlight is very, very common in JavaScript. So you're going to see a lot of single if statements floating around. And the final one, if else, is when we need to choose between 2 mutually exclusive outcomes. So let's do an example of that now. For this example, I want to display a pop-up on our webpage, which is a New Year's discount on their product. But I want the value of the New Year discount to be different if the user is logged in or not. So let's declare a new variable, let user logged in equal true. Now, if user logged in is equal to true, we're going to output discount of $20. But if the user's not logged in, which is else, we're going to display a discount of $10. We want to reward our logged in users because they're members with a bigger discount than those not logged in. So this is an example of choosing between 2 different outcomes. Let's refresh. So you can see we get a discount of $20 because the value of user logged in is set to true. Let's change this value to false, so the user is not logged in. I'll refresh, and you can now see the discount is $10. Now the reason I also wanted to show you these examples is that previously we were just using the comparative operator, whereas in these examples we're using the equality operator. So both are really helpful inside if statements. So let's now take a look at decision making in action. Looking back at our EasyJet webpage, I want to look at logic that's setting the ticket price. Because with ticket pricing, it changes as less seats become available. So on the application, we'd have variables like this. let seat price equal the base fee of $35.99. We'd have the number of remaining seats, in this case 15. We'd have the total cost of the fare, which would initially just be set as 0, and the number of passengers, which in this case is 3. So to work out the cost of the outbound ticket, we first need to know the seat price. But the seat price changes depending on the number of seats. So we'd have an if statement like this. If remaining seats is less than 10, we want the seat price to be $39.99. In this case, our remaining seats is the value 15. 15 is not less than 10, so this would result in the Boolean value false, and therefore the block of code does not run. So the seat price is not updated. The total cost of the outbound fare would then be the number of passengers multiplied by the seat price. There's 3 passengers, and our seat price is just the base fare of $35.99, which gives us a total cost of $107.97. We could then output this value to the console using our tempered literals. So now let's go change the value of remaining seats to 5. So looking now at the if statement, our remaining seats is 5. 5 is less than 10, so this would result in the Boolean value true, which means that the code block will execute. So the seat price is updated to $39.99. This means that in our calculation of the total cost, the seat price is no longer $35.99, but $39.99, which means that the new total cost will be $1197.97. So this is a great example of using a single if statement to set the price of a seat when the number of seats remaining goes below 10. Looking at another example, let's look at the code that's calculating the basket price based on the fare of the adult and children and the discount. We'd have some initial variables responsible for the number of passengers. We have let child passengers equal 2. We have let adult passengers equal 2. And then we could define a new variable for the total passengers, which would be child passengers plus adult passengers. We then have some variables relating to cost and pricing. The first variable would be total cost equals 0. That is, the initial cost is 0. We'd have the initial discount as 0, and would have the ticket pricing of the adults and the children. Now the discount is being applied based on the number of passengers. So we'd have an if statement like this. If the total passengers is greater than 3, then change the value of the discount to 76. So this if statement is used to change the discount value depending on the number of passengers. We would then change the value of total cost from 0 to the result of this equation here. We first work out the child fares, which is child passengers of 2 multiplied by the child ticket of $98.59. For the adult passengers, there's 2, and for the adult ticket price, it's $98.59. Now in our case, because the total number of passengers is 4, which is greater than 3, the value of our discount is 76, because the if statement is true. So we will be subtracting off a 76 discount. Now if the number of passengers was less than or equal to 3, the value of our discount here would be 0. So we end up with a total cost of $512.32. And we could output this to the console using our tempered literals. Now something else I want to highlight which is really important is that our code is running from top to bottom. So if the if statement was below the console.log, the value of our discount would still remain as 0. So this wouldn't be correct. So I did just want to note that if you are expecting your value of discount to change because of an if statement, that always needs to come first. Let's take a look at another example. We'll be looking at whether the user wants to sit together, people that really love their partners or family, and are willing to pay that extra amount. So looking at our variables, we'd have const the seat picking fee per passenger is $6.49. Now I'm using const instead of let here because on the application, the seat picking fee won't be changing. It's not a changing variable which I as the user have access to, like number of passengers or total cost. So that value is just not going to change. So I'm using constant there. We then have the number of passengers, which is 4, and the current total cost is sitting at $512.32. We then declare a variable sit_together, which holds the Boolean value true or false. In this case, I'm going to set it to true, which means the user has ticked to sit together. We would then have an if statement like this, where if sit together is equal to true, we're going to update the total cost. Now I'm actually using the compound assignment operator here, where if the condition is true, I'm adding to the total cost of the seat picking fee times by the number of passengers. The longhand of writing this would be total cost equals total cost plus the seat picking fee multiplied by the total passengers. But this is a great use case of using the compound assignment operator, where I'm just adding onto the total cost if the user does want to sit together. So if sit together is equal to true, this if statement updates the total cost, where the seat picking fee is $6.49 and the total passengers is 4, which would give us a new total cost of 538.28. And then we could output this to the console using our temperate literals. Now, if the variables sit together was equal to false, this code block wouldn't run, so our total cost would still remain at 512.32. All right, for the last example, we'll be looking at where the user can select different bundles. In this case, the user will be adding the Essentials bundle, which adds £50.48 to the ticket. For our variables, the total cost is currently sitting at 512.32, and the passenger selection has the value Essentials. We would then have a code block that looks like this. We again are using compound assignment to add 44.23 to the total cost. Else if the passenger selection is Essentials, we're using the compound assignment operator to add 50.48 to the total cost. Else if the user just selects Standard, there is no additional fee there, so we're adding 0 to the total cost. So this block of code is updating the total cost. And once again, we'll output this to the console using our temperate literals, where our total cost would be a value of 562.80. Now in this example, I've just done it for one passenger, but of course you could add to this to do it for multiple passengers. Now one thing I just want to highlight is that for this code, we don't actually need this last else statement. And that's because it's not actually doing anything new. If we don't select Standard or Essentials, the total cost is just 512.32. We don't need to explicitly go and add 0 to the total cost. So I can just remove that last else statement and just use if and else if, which is totally fine. You don't have to always end with an else statement. Now I also wanted to note that using else instead of else if wouldn't work. And that's because the else is a catch-all. If you recall, with else you don't go and give a condition like you do with else if. So if we just use else here, which acts as a catch-all, it would mean that we're always adding 50.48 to our ticket price if Standard Plus, which is the first condition, is not selected. Now that would just be totally wrong, because for the standard base, we're not adding anything. So what this means is that if we had this as an if-else statement as opposed to an if-else-if statement, Standard Plus would work fine, where we add 44.23, but then 50.48 will be added if the user clicks Essentials or Standard. So it's really important to realize the else is only used for a catch-all. And this is a good example of where you would use an if and else if statement without needing a catch-all else. So let's wrap up by building a summary card, if statements. I'll be going through the 4 different kind of if statements we can have. The first is a single if statement, which looks like this. We're just using the if keyword by itself without any additional checks. The second kind of if statement we can have is a binary if statement, which looks like this. It's binary because there's either one of 2 outcomes. If the condition is true, we'll execute what's in the first if block, whereas if the condition is false, the else code block acts as a catch-all. The next if statement is called a chained if statement, and it looks like this, where we use the if keyword, the else if keyword as many times as you like, and then a final catch-all else code block. The last if statement is called a multi-branch if statement, and it looks like this, where we use the if keyword and else if keyword as many times as you like, but there is no catch-all else. So I just wanted to end this video by summarizing the different kinds of if statements you could have. And we've seen throughout this video circumstances you'd be using each one. Now that you've mastered the theory so far in this video, it's important to understand how we can apply it in a real-world project. If you haven't been following along in other parts before this, I recommend you download the starter files in the description below and code along with me. This project is part of my JavaScript full course. You can join me for free on YouTube by clicking the video appearing in the top right now. So let's go and apply what we've learned to our BMI project. We're going to be adding comparison operators, and we're going to be adding an if statement. So this is where we're currently up to in our project. We've defined our variables, we have the BMI calculation being performed, and we have some output. Now at the moment, all we're outputting is the BMI value. The whole point of the BMI calculator is to categorize us as underweight, healthy, overweight, or obese. So now with the power of an if statement, we can begin to implement this logic. So the first thing we need to do is determine the range of values for the BMI calculation. I'm on cdc.gov, which is a health website for the US, and it shows us the BMI table. We can see that underweight is less than 18.5, healthy is 18.5 to less than 25, so that's like 24.999, it's not inclusive of 25. Overweight is 25 to less than 30, like 29.999, and obese is 30 or more. So just so we have an easy reference of this, I have sitting in my clipboard a multi-line comment I'm just going to pop over here, which shows me the values from that table. Now, something I want to highlight straight away in how this differs to the train example we looked at earlier is that these categories actually have ranges of values. For example, 18.5 to 25 is a range of values, which is specified by two numbers. We didn't have this type of case in our train ticket example. In our train ticket example, we just had up to 12, which is less than or equal to 12. We had 65 and above, that's greater than or equal to 65. And then the last value was just everything else, which was $20. So in this example, we have a less than, a greater than, and then everything between is just a single value, 20. That's different to this, where we actually have specific ranges we need to account for set by two different values. The underweight is the same as our children ticket, the obese is the same as our seniors ticket, but now we have set ranges of values. And we actually don't yet have a technique to deal with this with our if statements. So let's just go do what we can do. We can do this one. So if BMI is less than 18.5, what we now want to do is set the BMI category. If you recall back in the variables video, I just initialized BMI category. It doesn't yet have a value, but now using the if statement, we're going to go give it a value inside the code block. So we're going to change BMI value to the string underweight. The next one we can do is else if, and the condition we can do here is for obese. So that is when the BMI is greater than 30, we can set the BMI category equal to obese. But so far with our JavaScript knowledge, we actually don't know how to handle this, where we need to account for a range of values set by a lower value and a higher value. All we can do for now is a catch-all else, which we can just put the BMI category as healthy or overweight. That is, we're just capturing all the values between 18.5 and 30. Now in the next video, we're going to be learning about logical operators, which will give us the tools to fully implement this and handle a range of values like we have here. But this is a great start. We're beginning to write the core logic of the program with our if statement. Before we test this out in the console, I now want to output the BMI category to our message. We'll keep this as it is. Your BMI is the BMI value, and we'll say which is, and then I'm going to grab the BMI category. All right, let's go play around with this in the console. All right, it's entering the weight in kilos, 80, my height in meters, 1.75, and M for male. Let's open up the console. We'll show my BMI, and currently I'm in the range healthy or overweight. All right, just a small typo here. This should be healthy. All right, let's go redo this with some different values. I'm going to enter quite a low weight of 30, a height of 1.75, and M for male. Your BMI is 9.79, which is underweight. Okay, this seems to be working. Let's go redo this, and I'm going to enter a large weight of 500 kilograms, 1.75 meters, and M for male. Your BMI is 163, which is obese. So this core logic is working really well. So in the next video, we're going to be learning about logical operators, which will allow us to handle these cases here. If you've enjoyed this style of teaching and are looking at mastering JavaScript, you can join me in my JavaScript full course, which is available for free on my channel. The course is designed for complete beginners and covers everything you need to know to code JavaScript at a professional level. In the course, you'll experience the same high-quality teaching and build a whole range of real-life projects from scratch. Join me today and also make sure to subscribe to the channel to stay in the loop with new releases. See you in the JavaScript full course.